Hey everyone, in this video, we're diving into some essential machine learning concepts that every beginner should know. Underfitting, overfitting, and generalization. These three terms are super important because they help us understand how well our machine learning models are learning from data and how they perform when faced with new, unseen data. In simple terms, underfitting happens when a machine learning model is too simple to capture the patterns in the data. It doesn't learn enough from the training data, which leads to poor performance on both the training and testing data sets. Here's a more straightforward explanation. Underfitting is like trying to fit a straight line through data that's actually curved. Since the model is too simple, e.g., using a linear model for data that has a non-linear pattern, it fails to capture the complexity of the data. This usually happens when the model is not complex enough, or there's not enough training time, or the features used are not sufficient. So if your model struggles with both training data and new data, test data, it's likely underfitting. Let's also understand with a video.
If you're a student who loves to dance, then you need to see this robot's moves. Meet my robot friend, RoboBob. RoboBob only knows one dance move. Check this out. Now imagine RoboBob at a dance-off. Everyone's doing cool moves, spins, flips, moonwalks, and there's RoboBob, stuck with his one basic move. Kinda sad, right? This, my friends, is what we call underfitting in the world of data science. Underfitting is when a model is too simple to capture the complexity of the data. It's like RoboBob here, who can't keep up with the cool dancers. So, if your model is underfitting, it's like telling your robot to learn more dance moves. It needs more practice to handle the complexities of real-world data. Otherwise, it'll just be like RoboBob stuck doing the robot while everyone else is killing it on the dance floor. Remember, more moves mean better grooves. Keep your models sharp and don't let them RoboBob out. Until next time, happy dancing.
Overfitting happens when a machine learning model learns the training data too well, including its noise and outliers. This makes the model perform really well on the training data, but poorly on new, unseen data, testing data. In simple terms, overfitting is like memorizing the answers to a practice test. You get all the practice questions right, but when the actual test comes with new questions, you struggle because you didn't really understand the underlying concepts. It occurs when the model is too complex, e.g., too many parameters, too many layers in a neural network, and captures random noise instead of the actual pattern. So if your model does great on training data but fails on test data, it's overfitting. Let's also understand with a video.
Got a sec? Let's talk about why your pepperoni-only pizza habit is a lot like overfitting a model. Picture this, you're at your favorite pizza place, and every single time you order the same thing, pepperoni pizza. No mushrooms, no olives, nothing else, just pepperoni. Now imagine you're a pizza topping expert. You've trained your taste buds to recognize only pepperoni, give you a pizza with mushrooms, and you're lost. It's like you've never seen a pizza before. This is exactly what happens when a machine learning model overfits. It's trained so well on the training data, like your taste buds with pepperoni, that it can't handle anything new. Throw in a new topping and it's completely confused. Overfitting is like saying pepperoni or bust. But in the world of data, you need a bit of variety. So next time you're at the pizza place, maybe try a new topping. Your taste buds and your models will thank you. Thanks for watching. Stay curious.
Model generalization means that the model has learned the underlying patterns in the training data well enough that it can apply this knowledge to new, unseen data, test data, effectively. In simple terms, a well-generalized model strikes the right balance. It learns from the training data without memorizing it, avoiding overfitting, and is complex enough to capture patterns without being too simple, avoiding underfitting. This leads to good performance on both the training set and the test set, which is the goal in machine learning. So, when your model performs well on both training and test data, you can say it has achieved good generalization or an optimal fit. Let's also understand with a video.
I'm sure you've heard the news. 2 bakers, 1 kitchen, and a cookie battle for the ages. Meet Jane and John, both convinced their cookie recipe is the best. Jane's got a mountain of chocolate chips. John, he's all about that perfect crunch. The debate is fierce until our hero steps in. Why not normalize things? Think about it. Normalizing a model is like making sure every cookie in the batch gets a fair share of chocolate chips. No cookie left behind. It's all about finding balance so no ingredient goes overboard. So, Jane and John mix their batches. Voila, the perfect cookie is born. Crunchy and chocolatey. Just the right amount of everything. And there you have it, folks. Normalizing isn't just for math geeks. It's for bakers too. Who knew science could taste so sweet? Now go on, bake your best batch, and remember, balance is key. Happy baking.
Underfitting. When the model does not perform well on both training and test data, it is underfitting. This means the model is too simple to capture the underlying patterns in the data. Overfitting. When the model performs well on the training data, but poorly on the test data, it is overfitting. This happens because the model has learned the training data too well, including noise, and fails to generalize to new data. Generalization, or optimal fit. When the model performs well on both the training data and the test data, it is said to have good generalization. This means the model has learned the right patterns without memorizing the data, so it can make accurate predictions on new, unseen data. So, underfitting. Poor on training and test. Overfitting. Good on training. Poor on test. Generalization. Good on training and test. If you found this explanation helpful, make sure to like the video, subscribe to the channel, and hit the notification bell so you don't miss more content on machine learning and AI. Thanks for watching, and see you in the next video.